All right, ladies and gentlemen, hello and welcome back once again to the longest running show in the world about data. It's called DM Radio. Can't do a show without promoting Future Proof, the world's first made for TV webinar series. Check your local listings. We're in 15 markets, including DC, Silicon Valley, New York, Atlanta, Detroit, lots of different places, and on the Reveal streaming channel. I've checked it out there. It looks great. Let's dive right in. How do agentic data pipelines work? This is going to be fun, folks. We've got my buddy Sami Akbay of Dagen.ai, and of course, Mark Madsen, our buddy from Third Nature, is with us today. I just want to talk for a couple quick minutes about the history, how we got here in this entire data management world. So, what have we been doing for 40 plus years? We've been focusing on deterministic systems, building databases, making them stronger, faster, more performant, with more data types, more concurrent users, all kind of fun stuff. Applications sitting on top of that, networking, security, business intelligence took off. OLAP cubes, business analytics, process automation, all cool stuff. And then, so we're pushing this boulder uphill for 40 years. And then what happens is, oh no, it's coming down the other way, run away. Like this is the AI era. Now it's rolling down. And you have stories of AI deleting databases, production databases. Just from today, I saw a story all about that. These frontier models, well, they're probabilistic, aren't they? The frontier models. So they're very cool, they're very interesting. But one thing I've noticed is that we spent all this time building up deterministic systems and really focusing on quality. And one thing was never in question, and that was that you would get out of the database what you put into the database. Now, it is garbage in and garbage out. So if you put garbage in, you got garbage out. But if you put good stuff in, you got good stuff out. That is now in question. It's almost like we put a noise filter at the end of this 40-year process. Why would we do that? Well, the answer is these models are fascinating. They're very interesting. They're very compelling. They have all kinds of functionality. They're good at lots of different things, like ETL. They're good at very chunky, weird sort of ETL. Just throw it into a ChatGPT and say, hey, order this, and it does. It's kind of amazing. So there are lots of reasons why we're using them. We'll talk about that, but they are changing the access patterns. I can tell you that. So this is one of the funniest quotes I've heard on our show. Dr. Osama Fayyad, who was the first chief data officer at Yahoo years ago, back when they created Hadoop. You might remember Hadoop, the heady days of Hadoop. He said, these models, they're too big. They're not supposed to work. We don't know why they work. This is a guy who runs the Institute for Experiential AI out of Northeastern University. Very smart guy. He basically says, look, we don't know how they work. Well, that's not good for data governance, is it? For data quality? No. So deterministic versus probabilistic. Like I said, we've been focused on deterministic systems where we know what we get out of them. Probabilistic, we don't know. It's kind of fun for creative workflows, but not so great for reporting or for auditing or for production systems that have to deliver things on time. And it's really a hall of mirrors, isn't it? It's like all these reflections reflecting back at us. That's what the LLMs do, but they do interesting stuff. Well, I thought to myself, the one thing that they do not do, the one thing you should not try to do is put your guardrails for LLMs in the model because you don't control the model. We do not control the model, whether it's OpenAI or whether it's Anthropic with Claude or Google with Gemini. We're outside of that model. So your guardrails, how you actually shepherd and govern these systems, need to be outside, and that they need to be in the skills and tools section. So we'll talk about that today. That bullwhip that you use, it's not really a leash. It's a suggestion in a probabilistic world, right? You can have system prompts, all kinds of prompt engineering that can get you close to governance, but you'll never actually get there. So it's very important to understand all that. And Sammy, this was a quote from him the other day. I'm so excited to spend my day maintaining data pipelines, said no one ever. And with that, I think I'm going to hand it off to Sami Akbay of Dagen. Take it away.
Thank you, Eric, and good to see you, Mark. Let me start sharing my screen and tell me when you can
I
see.
can see it. Looks good.
Perfect. So today I'm going to talk about agentic data pipelines. This is a new concept that we've been introducing, and that's mostly because the data engineering and autonomous data engineering is something that's about to enter our lives in a big way because the emerging AI data infrastructure has some major changes to how we've dealt with data over the past years, right? And with that, let me start pointing out the few problems. Uh, You mentioned that you can control the model, but at the same time you can control, or if not completely control, you can govern the agents that run those models. And let's revisit that after I go through my slides. You heard the statistic, 88% of AI pilots never reach production. And the primary reason behind that is because data. You take a sample data set, you have some test data, you build an AI application with it, you show it to your business colleagues, they go, wow, this is great, let's put it into production. Then you go back to your data people and they say, well, being able to provide you continuously on an ongoing basis, a fresh set of data for that is not going to be trivial. And predominantly that's because of data engineering. And data engineers spend a vast majority of their time with data pipelines at the center of everything. Engineers got the cool things like Cloud Code, Cursor, Replit, Codex, and they've started to see tremendous productivity gains, right? But that also has increased the load on the data engineers and increased the load on the underlying data infrastructure. And that's the problem that we're trying to address. The world has changed, and that's probably an understatement, uh, but the data pipeline has not changed. What I mean by that is that the original data pipelines had one dominant job, right? Like they had to move data, and the data was being moved for the human analysts. That world still exists, and self-service BI is still critical. Reports, dashboards, I think they're going to be here to stay. But that world now shares the stage with something way more demanding that is driven by AI. In the past, everything we built around data engineering focused on human consumption of that data. The reports, dashboards, BI tools, analysts as the primary consumers. Now we have AI and human consumption, both of them being the consumers of the data, and AI agents and machine consumers for the first time are first-class consumers of the underlying data infrastructures. We need RAG systems that require AI data. We need LLMs that need to see denormalized data. The requirements are constantly evolving, and the patterns drive machine consumption patterns. So the static pipelines that we have used break under the weight of these AI native workloads, which is why we're now starting to talk about agentic data pipelines. An agentic pipeline is a data pipeline that knows why it exists, detects and repairs its own failures, and is orchestrated by AI agents that can reason, act, and learn over time. Now, let's dive into what that really means. The agentic pipeline in our thesis has three key characteristics. First, it is intent aware. Next, it's self-healing. And third, it's agent orchestrated. So let's look at that one by one. In the past, when we built data pipelines, we would do things like, okay, get data from such and such schema in Oracle and put it into Snowflake, or get data from Postgres and put it into BigQuery. It was a source and target pair and some additional information about where to get the data from, where to put it into, and then what kind of transformations to apply to that data while it was moving. What we need to do now is that while building those pipelines, talk about the business outcome that the pipeline is going to serve. Who is going to consume that data, and what is the acceptable quality? Because if the pipeline knows the ultimate goal of why it's being generated, using that metadata, using that context essentially, it can use AI models to figure out what is the optimum course to fix when something breaks. Things will inevitably break. You're going to have schema drift, you're going to have source changes, someone is going to put in an escape character or some bad piece of data that's not compatible with the pipeline that you've been building. And for different purposes, you want to handle those in different ways, right? For example, if I'm dealing with social media engagement data, I might decide to skip a record rather than try to manually correct it. But if I'm creating a report for the controller, I'll definitely not want to skip a record because that's going to change the aggregates, the sums, and you don't want to lose trust. And then, of course, all of this needs to be agent orchestrated, which means that every time you invoke it, it needs to observe what's going on, figure out if it executed as expected, if there was an anomaly, and then use agents to correct course or pull human in the loop as needed. So ultimately, agentic pipelines reason, they act on anomalies, and then they learn through this process. How have we implemented this with Dagen? From intent to self-healing pipeline in one shot, you essentially enter prompts, you talk to these agents, and these agents end up creating the flow end to end. And then you start with declaring the intent. You tell it, I would like to create a churn risk report for my CFO that runs on a daily basis, or I would like to create yeah, Instagram engagement metrics for my digital marketing team. It comes back with a work plan that it generates. It says that, well, this is how I'm going to carry this out. This is how I will build your pipelines and how I'm going to deploy them. You verify that that is exactly what you want, or you tell it, no, change this part. From that, it builds out the pipeline, and you can pick and choose where that pipeline gets deployed. Once that's done, you tell it to start running it at 2 a.m. every day, or start running it once an hour, or you can determine the cadence at which this is going to operate. And finally, you add the monitoring and self-healing, and you tell it, if you see such and such anomaly, uh, either pull in the human in the loop or try to correct it yourself, or you can be very explicit. There are a few cool things that happen while we do this. First of all, it uses the technologies that we're accustomed to in the modern data stack. It uses dbt, it uses Spark, it uses Airflow, all your favorite targets like Snowflake, BigQuery, Databricks, Redshift. We support all of those. More and more Iceberg these days. So there's some of the more emerging technologies as well. But critically, as this is building out your new pipelines, it institutionalizes the tribal knowledge using a knowledge base and using reinforcement learning. So let's talk about that memory a little bit. We divide the memory into three discrete layers. On the top layer, you have the episodic memory. Think of that as what is happening right now and the session information, the exchange that you're having as you're building the pipelines. It remembers the current information, the specific context, the immediate goal, and then the context has where am I getting this data, where am I pushing this data into. The second layer has procedural memory. These are the skills and the rules. So if I'm getting data from a specific source, let's say that I'm getting data from Salesforce, I'm putting it into Snowflake, I might have my best practices established for this, my golden thread that I want to follow. I can put that into the procedural memory and make sure that everything creates consistent artifacts as they operate the system. The third part, which is pretty, this is actually really valuable. It accumulates the long-term memory of the organization. As it
Hmm.
carries out these different tasks, what it does is it turns them into embeddings, vectorizes them, keeps lineage information, and remembers how you built things. As it remembers how you built things and accumulates this information, it gets smarter and smarter about your data estate as time goes by. So One other thing that I did not mention here is that there is a multi-agentic, hierarchical agentic structure here. When you're talking to the system, you're talking to a super agent, but then that super agent starts to distribute the tasks to subject matter agents under the cover, which gives us a couple different things. One of them is the ability to use the right model for the right task. For example, super agent will come up with the plan of action. It will tell the DBT agent to write some DBT code or the Spark agent to write some Spark code. Those agents are going to be fine-tuned and equipped with the right tools and skills specifically for that task, which gives you better token economics, cleaner code, more determinism, and everything is a lot cleaner as you keep accumulating this information in the system. So we think that agentic pipelines over time will replace the static infrastructure because we need an order of magnitude more pipelines if we're going to implement AI at scale. And just trying to monitor, fix, and instrument them by brute force and humans is going to be incredibly difficult and expensive. AI readiness is a competitive mode for organizations. People will want to implement more and more AI. And the longer people wait implementing an agentic system that learns and accumulates institutional knowledge, the more the cost of that will compound because the system learns and it accumulates information, and that's a big differentiation. And we think that we built the fastest path forward.
Hmm.
I'll stop there. That was a long monologue.
It was pretty good at the subject matter agent. That's fun. We know subject matter experts, SMEs. There will be subject matter agents, and I love the orchestration part. I love the three layers of memory. I just want to comment on that very quickly. I think that's very clever because you're reflecting what human beings have, right? We all have our own attention span. That's immediate memory, what you just said to me a minute ago, but you have sort of midterm memory and then long-term memory. And all of those come to the fore as a human being. And what you're doing is baking that into a system now, right, Sammy?
That's exactly what we're trying to do. So you can think of it as the episodic memory is the conversation that you and I are having right now, right? And then the procedural memory is what you learned at school or what did in the math class and all the examples that we solved to memorize and make it repeatable. And then the knowledge base is almost like, what your brain does when you're in your REM sleep and organizes the data, associates the right things with different constructs. And there is a lot of science behind memory. And I think 2026 is going to be the year of memory. I think you and I actually talked about that in the past. It's just going to really make successful agents or successful implementations differentiate themselves by using more complex memory patterns.
And I'll just get one quick comment from Mark before we launch the radio show. Everyone's talking agentic. I know you focus keenly on the probabilistic nature of the LLMs. Everything is hallucination if you get right down to brass tacks. But what are your thoughts about the evolution of data management as we hit this inflection point of agentic solutions?
I think there's two parts to it. I think, one part is you're using tools, or people are using tools to produce artifacts that do stuff, right? Which is more or less what we're talking about here, right? Versus these things are going to go off and solve problems of uncertainty and ambiguity without the capability of doing logical reasoning or causal reasoning, which language models do not do. So if you're going to go that route, which we hear a lot of promises about trying to use things that can't work that way to work that way, then you're in a different arena because now you're talking about making decisions around ambiguity and uncertainty. And that's the realm of the semantic aspects of data. These numbers don't look right, and I tell you, and you're the data engineer, and You're like, well, the math checks out, the code works, yeah, but something's wrong. I'm telling you these numbers don't look right, but I can't tell you specifically. And then we figure out that you pulled from the table in the dev system rather than the prod system, and so the numbers aren't right. And it's exactly the same table. It was the system identifier that it was a mistake. And whether it's generated code or humans, the same things can happen. But
Mm,
there's that's not a semantic difference even in the data. That's a semantic difference in the label that was attached to the data, which is basically where it comes from. It gets
mhm,
much worse when you start getting into the data and you say, which of these three, marketing identifiers is the thing I'm supposed to be using to link my data?
mhm,
That semantic change or semantic difference is stuff that sometimes the machines are good at discerning your intent, and sometimes the machines are terrible at, and then we call them hallucinations. And sometimes they need to be able to produce the did you mean A or B or C? And now we're talking about metacognition and logical reasoning, which again doesn't exist in these things.
mhm,
So now it becomes a subtle art of which kind of models are you using and how are you using them and where are you using them to deal with the language interface part of an LLM and this needs to be more correct than just random generation based on teasing out intent from words, which is over here.
So, Mark, I think you have a really good point there, which is one of the reasons why we avoid using models against the data. We try to use agents against the data because if I use agent rather than a model, I have the ability to put some more uh, like guards around the model as it interacts with the data. So I can put things like skills and explicitly tell the model every time you do X, use this skill. I can put rules, which like if then else, very binary. And then we also add the memory with lessons learned. So for example, if it used the wrong instance of the same data from dev rather than prod, and you had to pull human in the loop. Once that human in the loop actually goes and resolves that issue, that becomes a part of the knowledge base. And it then knows in a similar situation, this is one of the things to check for. It may not be able to give you the right answer, but it will know that this is one of the cases that I need to evaluate for. But you're right, like, the magic is the ability to do fuzzy operations. But if you're going to make it operational and useful, you need to make sure that those fuzzy operations don't overtake the overall task. The task is actually a combination of skills, rules, lessons learned, templates, and then also the inference from the LLMs.
mhm. Very good
Easier
stuff.
said than done, but
Yeah, that's right. That's why they play the game, is what they say in the baseball world, right? It's like this team is 14-0, this team is 1-12, and the 1-12 team can still win because that's why they play the game. And I'm actually reminded of a couple quick things, and then we'll start our radio show in just a second here. To a certain extent, the bad things that happen in this world remind me of a classic line from Excalibur where Uther Pendragon is calling for Merlin. He goes, Merlin, you come when you're asked and pay no heed when I call you. It's like, yeah, well, that's not what you want from the LLM because it is kind of like a magician, right? It like spins stuff up, it creates things, it generates spells that look fascinating, but it's fuzzy truth if you get down to brass tacks. And it sounds so convincing. That's the problem is it sounds very convincing, but you can tell it, no, you're wrong, and look harder. That was actually one of the fun observations we made just recently is that these engines can be kind of lazy. So why would they be lazy? Well, you can just imagine from the perspective of the model provider, like OpenAI or Anthropic, let's say you're paying your $30 a month. Well, at a certain point, you're going to be pushing the boundaries on that $30 value, and they're going to push back. So if something is hard, and I've noticed this recently, it's starting to ask questions like, do you mean X or Y, or what should I do? Because it doesn't want to just burn all those tokens answering a question that wasn't the question you asked. So there are these interesting similarities between the models and actual human beings, because guess what? You ask a human being a question, they may give you a competent answer. That's wrong. This happens all the time. It happens with the agents too. But folks, our radio show is coming up next. Be sure to send in questions if you want, and we'll be right back.